In this demo, I'm going to talk about the LightWalletd utilities, which is a collection of learning tools that has helped me understand better as a Zcash developer what's going on in the background. So let me start with running what I'm running. I got zbrad running here. This is running on a Raspberry Pi 5, for example. And I'm also running a LightWalletd, and you can also run a zainod. So first step, git clone the LightWallet utilities GitHub. Go ahead and change directory into the folder that we need. And let's change mod executable flags for each of these scripts so that we can run them. Do that real quick. And that should do it. So what we're going to be demoing is working with toGRPC, and I created a script for toGRPCurl, and it's connecting to my local LightWalletd, and it's listing the functions that are available to it. So as an example, let's get information about the LightWalletd. You can see that it's connected to zbrad 2.3 and the block height and whether it has t-address support. All right, so next up, let's say we want to get the latest block height as seen from the LightWallet. This is how you would do it. It produces the height and a hash in a serialized hash that may or may not be useful, but what's actually going on in the background, it's actually encoded in base 64. So we can actually change this. Let's convert it back to hex. And like this, you just paste the string and notice how the zeros are at the end versus at the beginning. This is little Indian versus big Indian issues. I have a link in the repository on Learn Me Bitcoin that talks about this, but as a developer, all you need to really do is byte flip the string here, and I have a little Python script that I discovered reading through the LightWalletd issues. So shout out to the creator. And so let's run this, and because as it turns out, these strings are not always usable unless they're in a certain format. So we'll paste that there, and there we go. So what does this represent? It represents the block header hash, or the block hash. So we can, for example, run the git block RPC on zbrad to pull up the block using that hash. So as a demo, let's check it out. Go into where I have access to my zbrad RPCs. We'll call git block and plug in that hash, or that ID. There we go. So what else can we do? Let's go back to our LightWallet utilities folder, and we'll list the methods that are available, functions. What if you want to call it a specific block? This toGRPCurl supports that. You just call get block and then the block that you want to find out about. Let's do 298.0.0.0.0. and spits out a lot of information. But let's say we want to zero in on the hashes. We can use JQ to beautify and narrow down. So this is how you do it. Pipe it into JQ, filter for VTX array, and then we want the hash field. Oh, spelled VTX wrong. Hang on. There we go. So these are the serialized transaction IDs that was spit out by LightWalletd. So it is the same process as the block hash. We can encode and byte swap these and plug that into an Explorer so that we can see the transactions. So let's do this now. There's our hex, but now we need to byte swap it, or byte flip it. And there's our transaction ID as we're used to seeing it. So I will, for example, run the get raw transaction RPC on Zebra to get the details you may or may not be looking for. Very cool. So the last thing that I'll demo is, let's say you want to get information about a transaction itself. So there is also a get transaction function available on LightWalletd. And it takes as input a hash. Or they call it a transaction filter, but it's really just a hash. So what I'll do is, to get the hash we need, I'll just run the same command we did before for that block, and it'll list the hashes that we can use as inputs, and we'll run one of them. And we'll do the second one as well. Just keep it simple. All right, plug it in. And oh, I spelled transaction wrong, of course. And notice the data field, serialized as the others are. So let's convert it. Now on this one, you don't have to byte swap it. It just works directly. But it's going to be a big hash. So there's two ways we can utilize this. We can use zcashd and decode raw transaction, or we can use Zcash dev tool. So let's do the Zcash dev tool first. So we're going to get that outputted hex, and we're going to run the inspect option under Zcash dev tool. So -- inspect, paste your blob, and what do we get? Just making sure I got it right. We got the transaction ID, we got the version, and the information stored. Now, if you're running Zcashd, it has the decode raw transaction, which will do the same thing, but decode it in JSON format. So we can use JQ, and this will give us all the details that you would normally expect running a full node. So I hope this was helpful and educational, and I'll see you around.